Hi everyone, you're watching the Skywatch Media News Channel, and here's what's happening for the week of October 15th, 2018. Planet Earth narrowly missed a rare meteor storm from a passing comet earlier this month. The outburst occurred as Earth bypassed a filament of cosmic debris from a comet called Giacobini-Zinner. If the filament had shifted in the direction of Earth by a mere 500,000 miles, or by 0.0005 AU in astronomical units, our planet would have experienced a worldwide meteor bombardment of over 1,000 meteors per hour. A computer model from the University of Western Ontario's Meteor Physics Group shows how the Earth managed to bypass the gap between the two filaments of cosmic dust. The research model actually predicted the outburst before it happened. Meteors seen over Europe came from the larger filament on the right. According to this model, both the L1 and the L2 areas were forecast to have storm-level activity, particularly the L2 filament, which would have produced a worldwide phenomena in the range of 4,000 meteors per hour. This model prompted NASA to carefully examine the potential dangers to both spacecraft and satellites in this vicinity. The U.S. has 4 operational weather spacecraft in the L1 vicinity, whereas only 1 is operational from the L2 vicinity, where most of the activity was expected to occur. The European Space Agency shut down operations from their L2 position for several hours during the peak of the storm. They did it by reorienting the spacecraft towards the incoming debris. According to NASA, the meteoroids that came our way from Comet 21P were ejected by material that is more than a half a century old, rather than from the close approach of the comet in early September, which was considered by some observers to be the cause of the meteor storm. Comet 21P is classified as a periodic comet with an orbital time frame of less than 200 years. In the wake of the devastation wrought by Hurricane Michael, there is a great deal of concern about the reason why these storms are rapidly exploding in strength in recent years. Indeed, the unforgettable and incredible thing about Michael is how rapidly it became a near Category 5 storm that quickly ascended upon the Florida Panhandle. Floridians had known that a storm was approaching, but what they didn't know was how strong the storm would actually be at the time of its landfall. On the morning of October 9th, Michael was already a strong Category 1 storm, with an official forecast of Category 3 by the time it made landfall. But just 12 hours after the official forecast, the storm was already far stronger, increasing by more than 30 miles per hour. In a matter of one day, the storm leaped from a Category 1 to a Category 4 while continuing to intensify. During this time, the pressure plummeted to 919 millibars, becoming one of the lowest measures of any hurricane that made landfall in the United States, coming ashore at 155 miles per hour. Michael became a borderline Category 5 storm that most likely would have increased in strength if it had not yet reached landfall status. Even so, Michael made history as one of the 4 strongest hurricanes to ever hit the U.S. mainland. The rapid intensification of these storms is of great concern, not only to coastal residents, but also to the meteorologists who track these monster storms. As a matter of fact, all of the strongest hurricanes of the past 2 years have all rapidly intensified. Hurricane Maria increased by an incredible 80 miles per hour, leaping from a Cat 1 to a Cat 5 within 24 hours, just prior to its catastrophic landfall in Puerto Rico that claimed the lives of thousands of people. Both Harvey's and Michael's intensification occurred in the crucial hours prior to making landfall. Intensification of these storms will occur in warmer water, which is absent of wind shear. Hurricane Michael had crossed the waters of the Gulf of Mexico that ranged from 1 to 2 degrees warmer on the Celsius scale than would normally be during the month of October. This equates to nearly 2 to 3 degrees warmer in Fahrenheit, which accounts for the enormous increase in energy output prior to its landfall. Climate scientists are now focusing attention to this alarming phenomenon. Simply stated, as the ocean currents become warmer, the intensification of these storms becomes more dramatic, dropping more precipitation with the threat of higher storm surge. As with all catastrophic storms, our immediate thoughts need to be with those directly affected by them. But we also need to acknowledge that our long-term plan should be in the implementation of ways in which to better prepare for the onslaught of horrendous storms that will undoubtedly come our way. Our world is changing. The changes can occur rapidly, or they can occur over long periods of time. But they do happen, and once the horse is out of the gate, it is difficult to stop. On the Mediterranean island of Sicily lies the great volcano Mount Etna. According to a recent publication, the massive 10,000-foot mountain is sliding towards the Ionian Sea at about 1/2 inch per year. Not exactly at lightning speed, but still moving at a consistent, steady pace towards the sea. Mount Etna is Italy's most active volcano, and yet it is slowly sinking into the water that surrounds it, which has geologists concerned that a potentially disastrous collapse of the volcano could occur at some future date. As geological records of past events indicate, other volcanoes with instability issues, such as Mount Kilauea, have in fact caused their craters to collapse under their own weight, resulting in catastrophic events for those living in their shadows. Mount Etna lies in the midst of cities and farms, and is therefore in a precarious state. Nearly 8,000 years ago, it is documented that the eastern flank of the volcano collapsed, triggering a 100-foot tsunami that wiped out an Israeli community nearly 1,000 miles across the Mediterranean Sea. Using transponders to measure the movement of Mount Etna and the shifting of its flank, the recent study has shown that a movement extends well into the sea, affecting a much broader area. Therefore, movement away from the actual heart of the volcano means that flank movement is not caused by rising magma. Instead, the main force of the flank movement is gravity. Previous research suggested that Mount Etna would collapse from a massive eruption that would destabilize the mountain. But now the theory focuses more attention to the study, which indicates that tectonic plate boundary shifts could become the catalyst that pushes the volcano over the edge, rather than the eruptions themselves. In early October, Elon Musk and the SpaceX program launched the Falcon 9 rocket from Vandenberg Air Force Base just north of LA. The launch made for some stunning images in the evening sky. We often marvel at these visual spectacles because they manage to captivate our minds and they intrigue our curiosity. But as captivating as they are to the human eye, they only last for a moment in time. When you look to the sky, you are looking at a grand spectacle that lasts a lifetime. The stars and planets that fill the night sky do not fade away. They are always present for you to see. They are permanently fixated into your visual memory of the heavens. No earthly spectacle can outperform the grandeur of the sky. But all too often we take the sky for granted, relying most often on artificial spectacles for our delight, rather than the natural beauty that yearns for attention. If I were to say that the sky has turned red, would you then look up? The sky paints a continuous flowing portrait of our universe. If only you would take the time to look up and see its splendor. Thanks for watching.